The digital signal processor in this board is the C5515, and if you're not familiar with a digital signal processor chip, it's something like a microcontroller but optimized for specific operations. So a digital signal processor can be a fixed point or a floating point device. The fixed point device is designed for integers and fractions. It's usually cheaper, faster, and have low power. The floating point devices are designed for floating point data types. If you're not familiar with floating point data types, you can see it like something similar to scientific notation of numbers. Yeah? There's a value that dictates precision and an exponent that controls dynamic range. And usually the floating point devices, they have a larger dynamic range, but in comparison to the fixed point devices, they are more expensive and they use more power, and sometimes they are slower. Another important part of the digital signal processor is the number of bits. In a very superficial explanation, the number of bits can be seen as the size of the data units that the processor can work with. So for example, for the C5515, it's a 16-bit fixed point processor. And there are also processors which are 24 bits, 32 bits, 64 bits, and all these bits are related to registers, to memory, to addresses. So yeah, in a very superficial explanation, it's something like the size of the data units that the processor can handle. Another important thing to note is the JTAG. So here in this block diagram, we've seen that there is this JTAG interface here, and the JTAG, it means the joint test action group. So it's an interface that provides a way to communicate directly with the chip, and it allows testing, programming, and debugging. Yeah? And also the components in a board can be daisy chained and they can be accessed.